Okay, we're going to pick up on some integrals here, more integrations. These are among the most difficult integrations you will have to encounter. And we use trigonometric substitutions to solve these. And this is to the third power dx. So in this case, we are going to use a trig substitution where x equals a secant theta, and dx is a secant theta tan theta d theta. And so we insert our substitutions, and we got x, which is a secant theta. We have our square root, which has a squared secant squared theta minus a squared cubed, and dx is a secant theta tan theta d theta. We kind of ran out of room here. Try and keep that separate visually. Okay, now we just kind of consolidate things and see what we have. We know that 1 plus tangent squared theta is secant squared theta. And so under the square root, I gotta check this.
Call from.
Yes, I have 2 prescriptions waiting for me. Okay, back to where we were. Okay, so let's consolidate everything. So we have a squared so far, secant squared theta, tangent theta, and now under the square root, we know the identity. This identity gives us a squared tangent squared theta, but that's raised to the third, and this is d theta. So let's bring one more step, and we have a squared secant squared theta. Now that's tangent to the 6th. So we have a to the 6th, tangent to the 6th theta, but that's on a square root, so that's a third, tangent third, when you take the square root. So we have that multiplied against tangent, so we have a to the third, tangent to the 4th, theta d theta. Okay, now we bring out the a to the 5th, and we have secant squared theta, tangent to the 4th, theta d theta. Now, we can see how we've reduced this to a simpler problem now, because when we recognize we have u, if we use a u substitution, equals tangent theta, then du equals secant squared theta d theta, and that's what we have. We have u to the fourth, so we have a to the fifth, u to the fourth, du. And we've simplified that to a polynomial expression. So now we have a to the fifth over 5, u to the fifth plus c. Now all we have to do is go back to our original variables, where we have a to the fifth over 5, u to the fifth, which is tangent to the fifth theta plus c, but we're not done, because tangent theta, we have, we defined theta to be, the secant of theta was x over a, so x a, and this is, we got a squared plus b squared equals x squared, so b equals x squared minus a squared square root. So x squared minus a squared, so tangent, we got a to the fifth over 5, tangent to the fifth, which is x squared minus a squared over a to the fifth plus c. Now we can reduce that using algebra. And so that's 1/5 times x squared minus a squared to the 5/2 plus c. And that's our result. We got x squared minus a squared cubed dx, and that's our final result. So we can box that. That one wasn't as hard as some of them. X over the square root of x squared plus a squared cubed dx. Now that looks pretty intractable, but when we use this trig substitution, we got x equals a tangent theta, and dx equals a secant squared theta d theta, and we just plug that in and see how things shake out. So let's see, we've got a tangent theta times a secant squared theta d theta, and that's on top of x, let's see, a squared tangent squared theta plus a squared to the third. But we know that 1 plus tangent squared theta equals secant squared theta. So down here we got a tan theta squared secant squared theta d theta all over, that's the square root of secant to the 6th, so a secant to the 6th. So we got a to the 6th, secant to the 6th theta. But now that's under the square root, so now we have a squared tangent theta, and we have this bottom half is a to the 3rd secant to the 3rd theta, and so secant squared cancels with that, and we have a to the 3rd secant theta d theta, and we have then down here 1 over a tangent theta over secant theta d theta. But if we multiply top and bottom by secant, we got 1 on a secant theta tan theta d theta on secant squared theta. And let's take a look. We can use a u equals secant theta, and du equals secant theta tan theta d theta, which is what we got in the denominator. So now we go 1 on a u to the negative 2 du. And then that turns out to be 1 on a u to the minus 1 minus plus c, and now we go back to our original, so we have to work backwards. 1 on a, 1 on secant theta plus c, and so we have secant theta was given as, or tangent theta was given as x on a, and so this is x squared plus a squared, and secant we know is minus 1 on a cosine of theta plus c. So in the end result we have minus 1 on a cosine of theta, which is a on the square root of x squared plus a squared plus c. But those a's cancel out, and we can rewrite the whole answer to be we'll rewrite the whole thing to be minus 1 on the square root of x squared plus a squared plus c. And that's this integral x it was an awful looking integral, x squared plus a squared to the 3rd dx. So that's our result. And that's what we have. Just checking to make sure that everything is correct. Yeah, that looks right. Okay, so this is our result. The thing is, we have to be careful when we do these things because it's so easy to make a mistake. So yeah, tangent theta we defined as x over a. And so this is x squared plus a squared under the square root. And cosine is a over the square root of x squared plus a squared. So everything looks copacetic. That's the result. Okay. We've got dx over. Now these are all problems that I solved that were in the Handbook of Physics and Chemistry. Plus a squared to the third. So these are integrals that I guess they figure that you're going to run into in science. So it's good to have these solved. Again, in this case we use x equals tangent, or I'm sorry, a tangent theta. I always forget that constant, but you can't. It's important. So dx equals a secant squared theta d theta. And we make our little substitutions. So we got a secant squared theta d theta for dx. And down here in the denominator, we have a squared plus a squared tan squared theta plus a squared to the third. And we recognize that 1 plus tangent squared theta equals secant squared theta, identity. Plus we got an a squared down there, so everything is raised to the sixth. So we got a secant squared theta d theta on top of, now this is a to the sixth secant to the sixth theta. And when we take the square root of that, we have a to the, let's see, a over a to the third is 1 over a squared, and we have 1 over secant theta d theta, but that's simply a squared cos theta d theta, or cos theta d theta. And we know that y equals sine theta, dy equals cos theta d theta. So sine theta equals, and I should make this more accurate. You gotta be careful. So that's what we've got. So here we've got 1 over a squared sine theta plus c. Now we go back to the original. So we have theta is x on a, x squared plus a squared, and so that is x on square root of x squared plus a squared plus c. And that's our answer. And I'm in my notes, I got that one right. So we can move on to the next and just make a shorter video. So in this one, we have x squared over x squared plus a squared, no third power, dx. So again, we go x equals a tangent theta dx equals a secant squared theta d theta. And so we have a squared tangent squared theta times a secant squared theta d theta. And our denominator is the square root of a squared plus a squared tangent squared theta. But we know that is secant squared theta. We got 1 plus tangent squared theta equals secant squared theta. So the denominator is simply the secant of theta. So we have a squared, or a to the third, tangent squared theta, secant squared theta, d theta, over a secant theta. And then we take a look and see what we've got. So we got a squared, we can pull out here. Now, if we cancel that out, our integrand becomes tangent squared theta secant theta d theta. So if we use u equals tangent theta and du equals secant squared theta d theta, we end up with an integrand of u to the, what is that, squared, and we have du, and we have secant theta would be square root. Well, we don't go anywhere. We go back to the original problem. So that doesn't help us any. So let's take a look at what other little tricks up our sleeve we can use. So I don't want to go back to the original problem. We just make a full circle. So let's take this, and we've got a squared tangent squared theta, secant theta d theta, and then let's try our trigonometric identity. We got secant theta d theta, because we're using this identity up here. Let's get rid of this thing. And we're using this identity. We're using tangent squared equals secant squared theta minus 1. So we got a little erasing to do. Let's do it carefully. Okay, so that equals a squared. Now we have secant cubed theta d theta minus a squared secant theta d theta. Now, we've already solved secant to the cubed, and that was by parts. It was a difficult integral, but our result was secant theta tan theta plus, I think it was ln tan theta plus secant theta. So let me go check and just make sure. I don't want to just jump to conclusions from my memory. We'll have to go back to a previous video and look at my solution for that, because I don't feel like re-deriving something we've already worked on. So going back to my original video, which has, let's see, which one has the
2 plus 1.
I think it was in this video that I did secant to the third toward the end. So let's see. Yeah, I think that's it. That's the one. There was an awful lot of work that went into this. Let's see. Make that a full screen. And yeah, secant to the third theta. Yeah, I did have the let's see, where did that 2 come in?
Probably one of the hardest
Okay.
integrations.
I don't know why that video keeps coming on. Okay, I'm just making sure that I have the right solution here. So this ends up being minus a, so that's plus 2. Everything is divided. So that secant to the third. Now let's make this little note down here. A squared secant to the third theta d theta. When we solved it, was a squared over 2 secant theta tangent theta okay, tangent theta, and plus a squared over 2 natural log of secant theta plus tangent theta plus c. Okay, so that's our solution at this point. So we'll plug that in here. We got a squared yeah, a squared over 2 secant theta tangent theta plus a squared over 2 natural log of secant theta plus tangent theta minus a squared secant theta d theta plus c. Now, I'm just going to erase this result. And, okay, now all we're left with is the integral of the secant of theta. And that's something that we solved already. The secant of theta. We have secant theta times secant theta plus tan theta d theta over secant theta plus tan theta. So what we have here is u equals secant theta plus tangent theta, du equals secant squared theta plus secant squared secant theta plus tangent theta d theta. And that's what we have. It ends up being a 1 over u du situation. And so that's a natural log. So what we do is that we have a solution for that integral, the last integral, and that's the, let's erase all that. We don't need all this. Okay. Now, we end up with this bear of a solution, square, secant theta tangent theta plus a squared over 2 ln secant theta plus tangent theta minus, now this is going to be a squared natural log of secant theta plus tangent theta plus c. We have the two terms that subtract one another, so we end up with an expression secant theta tangent theta minus a squared over 2 natural log of secant theta plus tangent theta plus c. Now we have to put everything back in original terms. So we know that we've chosen x over a as the tangent of theta. So this is x squared plus a squared. So now we have secant equals. Now these are both going to be over a. So this is going to be 1 half x square root of x squared plus a squared minus a squared over 2 natural log of the secant is x squared plus a squared over a plus x over a plus c. And that's our final answer. So this turned out to be an interesting problem. And using our solution from before for secant to the third helped us get to this without having to use 2 screens worth of space. So we have x squared over x squared plus a squared dx. And that's our solution down there.